So there's this volcano in Central Oregon, right? It's been quietly pumping out enough carbon dioxide to kill whole forests. And get this, 611,000 Americans live nearby. Totally clueless. Most of them have no idea what a caldera is, let alone that they're practically living inside one. This isn't some sharp, pointy mountain you'd recognize from a postcard. Nope, it's a huge, gentle bump 17 miles across, just chilling there in plain sight. Families camp by two beautiful lakes on its surface, totally unaware the water is actually filling old eruption craters and that the ground under their tents is still warm. There's this patch of dying pine trees near a spot called Horseshoe Bend. That's one place where the earth itself is breathing out gas, pushing the oxygen out of the soil. The gas? You can't see it, can't smell it, but it's a direct message from a magma chamber the size of a city, stirring around 4 miles down. Before I get too deep into the details, a quick favor. Tell me in the comments where you're watching from. It helps me understand where this info is landing, because these silent giants aren't just in one state, they're connected, and knowing how close you are to one is a first step. Now, something important. A lot of people who find these updates useful don't actually hit subscribe. And no, this isn't about me wanting more subscribers for ego points, it's about making sure I can keep getting this information out. If you find this work valuable, seriously, just take a second and click that button. Think of it as a backup plan so you don't miss the next urgent update when things change. It seems small, but it makes a big difference. Let's get into it. Here's the real story. The Newberry Volcano isn't a mountain in the usual way. It's a caldera, which is basically a huge hole left behind by an eruption so massive it's hard to even picture. The whole city of Bend, with its 109,000 people, could easily fit inside this thing. Those popular tourist spots, Paulina Lake and East Lake, they're not just regular mountain lakes, they're volcanic vents that filled with water, sitting right on top of the active guts of the volcano deep down. And that's something they definitely don't put in the brochures. The ground pushing up, the gas-killing trees, those tiny earthquakes, these aren't just normal volcano stuff. They're signs of a huge volcanic system starting to wake up after being quiet for 1,300 years. And the timeline? Nobody ever told you this part. This isn't some new threat. It's super old, with its story written in layers of ash and glass all over the continent. About 600,000 years ago it started. A hot spot under the moving North American plate began leaking basaltic magma, building this huge, low-profile shield volcano, wider than it was tall. For thousands of years it erupted one lava flow after another, creating a structure 500 square miles big that's bigger than 3 entire cities of Portland. It grew not from big dramatic explosions, but from a steady, constant pileup of lava. Then, around 75,000 years ago, the volcano changed its game. A massive amount of explosive magma, full of silica, gathered under the top. What happened next was a caldera-forming event. The mountain didn't just explode outwards, it caved in on itself as the magma chamber below emptied in this furious burst of ash and superhot flows. It punched a 17-mile-wide hole in the earth. You can still find ash from that event, a faint layer all across the American West. It was something on a scale that nobody alive today has ever seen. After it collapsed, the system didn't just die, it moved into a new phase. Over the next 70,000 years, magma kept pushing up through the cracked floor of the caldera. It built smaller cones, pumice rings, and lava flows inside that massive hole. The two lakes, Paulina and East, formed inside two of these smaller overlapping craters. It became this complicated layered system, a volcano, inside a volcano, inside a volcano. Wild. Right? The last big eruption happened about 1,300 years ago. This wasn't a slow lava flow, no. It was a really violent, explosive event called the Big Obsidian Flow. A vent opened up on the side of the central pumice cone and shot out a cubic kilometer of glassy black rock and a towering column of ash. The lava flow itself moved incredibly fast, like a creeping wall of hot glass that covered a square mile in just days. The ash cloud drifted northeast, blanketing the area that would one day become Bend. Indigenous stories from the Confederated Tribes of Warm Springs might even carry echoes of this, a legend about a mountain breathing fire and glass. After that, for over 1,000 years, the volcano was quiet. Then came all our fancy instruments. In the late 20th century, geologists started noticing weird stuff. Patches of forest were dying for no obvious reason. The ground itself, measured by sensitive satellites, was subtly getting bigger. By the 2010s, they found a bunch of small, deep earthquakes right under the center of the caldera, like a rumble from that magma chamber 4 miles down. By 2018, studies confirmed the ground inside the caldera was actually rising a few millimeters each year. And those CO2 monitors they put in the dead tree zones? They were showing higher and higher numbers. The 1,300-year silence was definitely over. The instruments were listening, and the volcano was talking again. I mean, we just covered over 500,000 years of geology. This whole system is massive, and its history shows it can both build slowly and destroy catastrophically. Does knowing all this history change how you see those calm Central Oregon landscapes? Let me know in the comments. Your thoughts actually matter. Now, picture this. You zoom out from the planet, you cross the Pacific coast and the green Willamette Valley. You rise over the Cascade Range, past those famous peaks like Mount Hood and the Three Sisters. To the southeast, you won't see a sharp mountain. You'll see a low, broad, forested dome stretching across the horizon. That's Newberry. It doesn't look like a volcano. It just looks like a big plateau. Its top isn't a point, but a huge 17-mile-wide basin with 2 lakes, tons of campsites, and a maze of hiking trails. Now let's get down to ground level. Highway 97, the main road through Central Oregon, runs right along the volcano's western edge. Places like Sun River, a resort with thousands of people, and La Pine, a town of 2,500, are built directly on lava flows that came out of Newberry. 20 miles north down the gentle slope of this shield is Bend, Oregon, a city of over 100,000 and the fastest-growing metro area in the state. Its residents get their water from the Deschutes River, a river whose path was carved out by the volcano itself. Basically, all of Central Oregon's money-making and transportation relies on this sleeping giant. This is what almost no tourist and very few residents really get. How this volcano works makes it uniquely dangerous. It's what they call a bimodal system. That's a fancy word for a volcano that can erupt 2 totally different kinds of magma. It can make basalt, which is hot and runny, creating long, fast lava flows. But it can also produce rhyolite. That's a thick, sticky magma that traps gas and tends to explode violently, causing huge ash clouds and super hot flows. So it's like having a system that could act like a Hawaiian volcano one day, and Mount St. Helens the next. The magma currently making the ground swell and the gas leak, that's thought to be rhyolitic. That's the explosive kind. Imagine the magma chamber as a giant lung, 4 miles under the caldera floor. As new stuff flows into it from under the earth, it expands. The rock above it gets pushed up like the surface of a slowly filling waterbed. That's the lift that satellites are measuring, a few millimeters a year. But as that magma rises and cools, gases trapped inside, carbon dioxide, sulfur dioxide, start escaping. They follow cracks in the rock, all the way up to the surface. Since CO2 is heavier than air, on calm days it doesn't just float away, it collects in low spots like creek beds and hollows. It sinks into the soil, pushing out oxygen. The roots of those huge pine trees can't breathe, so they suffocate, and the trees just die from the ground up, making these quiet, gray forests. This doesn't even need an eruption to happen. It's happening right now, an invisible, quiet threat seeping from the volcano's core. The closest and frankly terrifying example of this isn't another volcano. It's a place called Lake Nyos in Cameroon. Back in 1986, a sudden release of built-up CO2 from the lake bottom created a dense, invisible cloud that rolled down a valley, silently suffocating over 1,700 people and 3,500 livestock. At Newberry, the CO2 isn't from a lake bottom, it's from the magma chamber itself, and the entire caldera is basically a giant pressure relief valve. More people need to know this. If you think this report is useful, please hit that like button. It tells the platform that this is crucial stuff. And if you have family, friends, or anyone you know in the Pacific Northwest, share this with them. Knowing what's under our feet is a basic form of safety. Okay, now let's stack up all the dangers. They range from sneaky and local to truly massive and regional. First, the gas. Like I said, this danger doesn't even need an eruption. Carbon dioxide is currently being released at deadly levels in specific spots, mostly around Paulina Lake. These are called tree kill zones on maps. On a calm summer day, a hiker resting in a little dip in one of these zones could get dizzy, pass out, and never wake up. A family sleeping in a tent in a low-lying campsite could suffocate overnight. No sound, no warning. This is a quiet, creeping danger happening right now. The USGS has put up warning signs in some areas, but thousands of visitors come through every year, totally oblivious to the invisible threat in the air around them. Second, hydrothermal and phreatic explosions. Paulina Lake and East Lake aren't just sitting on top of the volcano, they're actually part of its inner workings. The magma heats these lakes from below. Hot springs and steam vents are all over their shorelines and bottoms. A sudden shift in the magma system, or something blocking a steam vent, could cause water to explosively turn into steam. That's a phreatic explosion, a shotgun blast of steam, boiling water, and shattered rock. This could happen with almost no warning, maybe a few minutes of intense, localized shaking. It would shoot debris thousands of feet into the air and send a wave of boiling water across the lake, instantly flipping boats and flooding shoreline campgrounds. This isn't just a theoretical idea. The biggest phreatic explosion craters from the last 10,000 years in North America are right here at Newberry. Third, lahar flows. The top parts of Newberry get a ton of snow in winter. If an eruption were to happen when there's snow, or if a phreatic explosion shot a lot of lake water over the Caldera rim, you'd get a lahar. That's a fast-moving mix of water, mud, and volcanic debris that rushes down existing river valleys. The main path north is the Deschutes River. A lahar from Newberry would funnel directly down this river, right through the resort town of Sun River, and towards the city of Bend. Models show a big lahar could hit Sun River in less than an hour, and Bend in less than 3. It would be a wall of mud, like wet concrete, moving at highway speeds, destroying bridges, roads, and buildings in its path. Fourth, a big Plinian eruption and ashfall. A repeat of the big obsidian flow-style event is what they consider most likely for a future magma eruption. This would mean a column of ash and pulverized rock shooting tens of thousands of feet into the air. The winds would carry this ash mostly north and east, right over Bend, Redmond, and the areas around them. Even a few inches of this gritty, glassy stuff would be disastrous for a modern society. It would shut down Redmond Municipal Airport, the only commercial airport in Central Oregon, for weeks or months. It would mess up and destroy car engines, paralyzing transportation. It would short out electrical transformers, causing widespread power outages. It would contaminate the water supply in open reservoirs like Ben's Bridge Creek. It would cause serious breathing problems for people. Central Oregon's thriving economy would just stop. Fifth, the Caldera forming event. This is the low-chance, huge impact scenario. The system waking up again on a scale like the eruption 75,000 years ago. This would be a disaster for the entire continent. The eruption column would hit the stratosphere, messing with global climate. Super hot flows would cover hundreds of square miles, wiping everything off the map. The ash cloud would blanket the entire Pacific Northwest and drift across North America, messing up farming, transportation, and business for a generation. This is the volcano's maximum power, a reminder of the sheer force at play, held back, for now, by 4 miles of solid rock. I know I've said this before, and I apologize for repeating myself, but it really is important. My viewership has jumped, but my subscribers haven't. Think of it this way. A geologist doesn't just check a seismometer once, they watch it constantly. Subscribing is your way of keeping a continuous watch. It makes sure these updates get to you. It's not just a click, it's a commitment to staying informed. Thanks for understanding why I keep bringing it up. Picture this. A family from Portland has rented a small cabin on East Lake for a week in August. The dad and his 10-year-old daughter are out in a rented canoe on a clear, still afternoon. The water is this ridiculously deep blue. It smells like pine and dust. The daughter dangles her hand in the water and says it feels warm, like bath water. The dad laughs, tells her it's just the sun. But later, as they paddle towards the middle of the lake, he feels it too. The surface of the water, which should be cool, is strangely warm. Then he sees a patch 100 yards away fizzing, like a freshly poured soda. He's been coming here since he was a kid and has never seen anything like it. A faint, weird smell, like a struck match, drifts over to them. He decides to paddle back to shore, this weird anxiety tightening in his chest. As they get closer to their dock, he sees a ranger truck parked by their cabin, lights flashing. The ranger is walking along the shoreline, waving people away from the water. The fizzing spot in the middle of the lake is now a churning circle of white water, and a plume of steam is rising into the calm blue sky. They were just paddling right over it. He realizes, with a cold, sinking feeling, that this calm lake is just a lid, and something below had just started to boil. What happens next? That's what nobody can answer. The United States Geological Survey has Newberry's alert level at green, which means normal. No evacuation orders. No official warnings beyond those few small signs near the CO2 vents. To most people, the volcano is sleeping. Just a geological curiosity, but the data tells a more complicated story. The ground is swelling. Gas is leaking out. The earth is trembling with small quakes that are too deep to feel, but they're a clear sign of magma moving. The last eruption was 1,300 years ago. For a human life, that's forever. For a volcano that's 600,000 years old, that's like last Tuesday. That quiet is the most unnerving part. The system could keep slowly recharging for decades, even centuries, before anything happens. Or it could hit a breaking point next year. The pressure could build until that rock cap fails and a new eruption begins. Geologists say a big eruption would have much clearer warning signs. Rapid and dramatic ground changes, big earthquake swarms, and a huge jump in gas emissions. But even their own reports have this chilling detail. A phreatic steam-driven explosion could happen with very little warning at all. So many questions. Why did CO2 emissions start going up noticeably in the early 2000s? And why are they only in specific predictable spots? Does the slow ground uplift just mean a stable magma body is slowly inflating? Or is it new, volatile magma pushing into the system? How do you even evacuate the 10,000 to 15,000 people who could be camping, hiking, and boating inside the caldera on a busy summer weekend, when a steam explosion might give you less than 10 minutes to react? And what's the line between preventing public panic and telling people the full honest truth about a risk that's unlikely in any given year, but geologically guaranteed over time? The people of Central Oregon are living on one of North America's most dangerous and complex volcanoes, and most of them have no idea. The real threat isn't some dramatic lava-spewing cone, it's this huge, forested shield volcano whose gentle slopes hide the sheer size of the furnace underneath. It's a system that kills silently with invisible gas and has proven it can totally reshape the continent. Right now, beside a gravel road near Paulina Creek at the edge of a ghostly gray forest of dead pines, there's a small plain metal box bolted to a post. It's a solar-powered gas analyzer. Inside, a tiny infrared beam measures the carbon dioxide in the air. Every minute, it takes a reading and silently sends it to a database in Vancouver, Washington. That number is a direct message from a body of magma bigger than the city it threatens, and tonight, that number will be a little higher than it was last night. The ground is still swelling, the gas is still leaking, and the caldera everyone forgot about is slowly, patiently taking a breath.